Hello everyone, welcome back to another exciting video. This video will help you to understand and solve the question according to quantum physics and nuclear physics that includes decay constants and hydrogen spectrum or energy levels, how to discuss them, how to understand these questions. So before getting to the video and getting to the questions, make sure you have subscribed the channel, like the video and press the bell icon so that every time a new video is uploaded, you'll be able to get a hold of that question. So starting with the very first question, we have state the formula for the de Broglie wavelength of a moving particle, state the meaning of the. So those of you who have studied the chapter already know that lambda is equals to h over p. Here lambda is equals shows the de Broglie wavelength. H and H is a Planck's constant, which is 6.63 into 10 to the power minus 34, and P is the momentum of the electron or the particle to be exact. So the second part is state the name of the phenomena shown by the electron and the crystal. Again, if you have studied the chapters, you know that this is a diffraction pattern made by the electron when it is passed through the atomic cluster, diffraction grating, sorry. So this is electron diffraction. For your information, these questions are from 2022, year 2022, A to P4. So if you want to get the reference hold of these questions, you can text me in the private. I'll send you the worksheet as well. So what this phenomena shows about the nature of electron. So this shows the wave nature of electron because the diffraction and interference is given by the wave. This is the property of the wave. So that shows the wave nature of electron. Getting on to the next part, suggest why this interested cause the phenomena in B. So, if you have studied the chapter, your teacher must have mentioned that the atomic spaces between the atomic crystal in an atomic crystal is just like is very comparable to the wavelength of electron. So we know that a diffraction is maximum. Diffraction is maximum when the wavelength is approximately proportional to the spacing. So the electron's wavelength is very much proportional to the atomic spacing of a crystal. So this satisfies this condition. So that is why the wavelength of electron and the spacing of the atom is comparable to each other. So we'll get the diffraction phenomena that we are having this that we observed here in this particular question. Now, the electron is accelerated through a different potential difference. The new pattern observed on the screen is shown in this figure 8.2. Let's get to the next part. Hold on. So the question they have asked is that state and explain the chain that has been made uh, to potential difference to create the pattern shown in this figure. If we get back to the portion where we have discussed the de Broglie wavelength, we have discussed H over P. Here, momentum. Momentum is proportional to the kinetic energy. We know that this means that momentum and de Broglie's wavelength has an inverse relationship. Okay, first of all. Then this means when the electron they have asked us to state this that has been made to the potential difference to create the pattern shown in this figure. We have discussed in the photoelectric effect that 1 over 2 mv squared is equals to stopping voltage, and work function is also given as uh, hf plus work function is equals to the kinetic energy of the formula of the electron. So keeping all these points in mind, wavelength and momentum has inverse relationship. So in order to for this, and also we can also put in the formal the concept that we can discuss in AS level, that smaller the wavelength, shorter the wavelength, more the dark and bright fringes would get closer to each other. We can also, you can also put that concept into it. So in order to create this pattern where the, in comparison, let me take you up a little bit up here. Here you could see in this vector that the circle have come closer here, which means that wavelength has decreased, momentum has increased. So wavelength must have decreased, shorter become wavelength, decreased. And as you could see here, stopping potential has a direct relationship with that. So potential difference must have increased. So these 2 points we can mention here. It's of 2 marks, so that will account for that vector. Moving on to the next part, we have state what is meant by photons. So photons are defined as a discrete packets of energies. So we can also write the formula of E is equals to HF, packets of energies for that. Or because it's of 2 marks, we can say quantum discrete packets of energy, quantum of energy of electromagnetic radiations. For 2 marks, we have to at least mention 2 points. Next, they have asked us, where we told electromagnetic radiation of varying frequency and constant intensity, varying frequency and constant in photoelectric effect. We have studied that frequency has a relation with the kinetic energy and intensity has a relation with the electrons, emit electrons, number of electrons. So let's just keep this in mind while solving this questions. At a certain frequency, we know that there is a certain threshold frequency below which no electron would. Threshold frequency is the minimum frequency that is required for an electron to get out of the metal surface. So, what is the question? At a certain frequency, electrons are emitted from the surface of the metal. The variation of the frequency and the kinetic energy of the emitted electron is shown in the figure. State the name of this phenomena. So, this phenomena is given as photoelectric effect. Already I've given you so many hints. So, it's photoelectric effect. Describe three properties. Describe three conclusions that can be drawn from the graph uh, in figure 7.1, that the conclusion may be qualitative or quantitative. So the first thing we can, first and foremost thing is that there is a frequency, threshold frequency below which no electrons are emitted from the metal surface. That could be our first point. The second point we could discuss, that's the value of threshold frequency, which we can get from the graph. I'll show you the value in the graph. I'll take you back on the graph in just a jiffy. So the third conclusion that we can derive from here is maximum energy of the electron frequency that is given. And the last point we could discuss, the gradient of the line is Planck's constant. What else we can discuss here? Here. How do we know that the gradient of the line is this? Because we have just discussed that E is equals to HF for quantum and H is equals to E over F. So E, what is the gradient? Gradient is given as Y over X. Okay, so Y is E, X is F. So yes, it is the gradient. Line of the gradient shows just the plan, gives us the Planck's constant. This is the threshold frequency that I was talking to you about. Let me zoom it in. We can get the value of this vector. No, 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 too much, too much, too much. So this value here is, this is 5, 5.2, 5.4. 5.4 times 10 raised to power 14. Hertz is the threshold frequency. We can give that from here as well. So the 3 points that we're going to discuss, I've mentioned them already. Uh, the threshold frequency. Second one is we discussed about maximum kinetic energy depends on threshold frequency. Gradient of the graph gives Planck's constant. We can also mention that, yeah, that's enough. If we want to find out the work function, we know that work function is given as h into threshold frequency, and we know we have value of threshold frequency. We could put the value into threshold. If you want to be more fancy, you can also do that part. 5.4 into 10 raised to power 14 hertz. The work function will come out to be 3.6 into 10 raised to power minus 19 joules, or in electron volt by dividing it by 16 into 10 to minus 19 can also give you an answer in electron volt, which would be 2.2 electron volt. Getting on to next question. Uh, the experiment B is repeated twice, each time marking one change state with the reason how the graph is obtained would compare with figure 7.1 when a different metal is used but keeping the intensity of the radiation same. Metal is same, intensity is same. So we already have discussed that if intensity is same, the number of electrons would emitted would be same. So what a different metal is used. Sorry, I misread it. I thought the metal is same. If a different metal is used, so the threshold frequency would be different, obviously, but the number of electrons emitted would be same. So we will not get to that part. So a metal, the same metal is used, but electromagnetic radiation of intensity is increased. So if the metal is same, so the threshold frequency would be same. Now, photon energy would be same, line would be unchanged, but the number of electrons emitted would be greater. Moving